Okay, so it's the third class already. So today we're gonna focus on relational and logical operators, so the if and the if-else statement. And then we're also gonna start to familiarize with our class projects, which is actually based on real data sets. So it's pretty cool stuff. So just to revise very quickly what we did last class. So we focused on matrices and vectors manipulation, and we saw that to access a vector, you only need one index. And if you have to access a matrix, you need two indices, of course. And we saw how to access a range of values. So here, for example, there is like the first row, access the first row and the values from column 2 and 4, and also how to access non-consecutive values. So here there is the second row and the values of columns 2 and 4. And also we saw that if you know the position of an element, you can also modify its value. So here it was 6 before, and then you wanna change it into 1. So you select the third position. But today we're gonna talk about relational logical operators. So basically, logical operators, the only thing they do is just make a comparison between two values. And so the outcome of a comparison for equality or inequality can be only 1 or 0, and 1 is it's true, and 0 is false. Here, for example, here we have this variable test. We want to compare p, this is 3.14, and we ask the question if p it's like smaller than 4, and of course it's true. And so when we check test, then the result is true. So yeah, I was looking for some examples, and I found these super cute videos about pingus and relational operators, and it's very short, so we gotta watch it.
It's not
Can
uncommon
you
in
hear it?
programming that we need to check whether certain conditions are satisfied. For example, we may need to determine if a value, such as a temperature, is within a certain range. Like for our friend here to be comfortable, anything higher than 15 degrees Celsius is too hot, while anything below minus 20 degrees is too cold. We need to write code to check if the temperature value is within the defined range. So how do we do this? With relational and logical operators. The current temperature value is stored in the variable temp. Let's first ask the question, is the temperature below 15 degrees? To answer this, we use the relational operator less than. The result is a logical variable, which can only take the value of true or false. True is represented by 1 and false by 0. Here, the result is 1 because the condition is true. Now let's determine if the temperature is above minus 20 degrees. We use another relational operator, greater than. Since the condition is true, once again, the result is 1. Now, although we checked two separate conditions, we still need to determine if the temperature is within the comfortable range for our friend. We can combine the two previous conditions using the logical operator AND. The result is true only if both conditions are true. If the temperature changes and isn't in the comfortable range, then one of our two conditions isn't satisfied, and the result is false. We now have a single expression that represents a comfortable temperature range based on our original criteria. We use the relational operators less than and greater than, and the logical operator AND. But there are other relational operators to help us compare values, and logical operators to combine conditions in different ways. There's only one problem. It's too cold for someone else here.
Basically, we have a bunch of relational operators that are this double equal to, not equal to, then greater than, smaller or equal, bigger or equal, and then the logical operators are and or not. We have other two, but we are not gonna use them. I never use them, but if you're curious, you can easily find it on in the documentation. The only important things to bear in mind is that please do not confuse like the double equal, that means equal to the one single equal that basically assign a value to a variable. So they mean two different things, and MATLAB reads them in two completely different ways. So it's very important to remember it. So you can compare a vector or a matrix to a single scalar value using these relational operators that we just saw. And as a result, you will have a logical array that is the same size of the original array. So basically, during this comparison, you ask where is that a certain condition is satisfied in the vector. So for example, here in this first example, we ask where in the vector, like a value, it's bigger than 12. And we see, so we ask, is 5 bigger than 12? No. So the result is false, 0. Is 10 bigger than 12? No. So the result is 0. Is 15 bigger than 12? Yes. And so the result is 1. And so the vector that you receive is going to be 0, 0, 1. And same logic for the other examples. So that's the super important part, and that is you will actually actively use while you code. So you can use a logical array as an array index. So in this case, MATLAB extracts the array's elements where the index is true. So for example, here, we ask where in the vector vec, the value is like smaller than 8. And so the result is going to be 1, 1, 1, 0, 0. But then taking these positions, you remember how to access like a vector or a matrix. It's basically what we saw last class. And so you access this vector using this index to extract these values where this condition is met. And so vector 2 is going to be, oh my goodness, this thing always pop up. So the vector 2 is going to have these values extracted. And so it's going to be 3, 5, and 6. So just to triple check, what this code in blue, what does this code in blue? What do you think is the output here of vec2?
Is it like 1, 1, 1, 0, 0?
Yes, exactly. So that's the difference. Okay. So you can also use the logical indexing. So if you wish to replace all values in the array X, for example, that are equal to 999 with the value of 1, you can use like this method. So you access all values that are equal to 999 in the vector or in the matrix, and then you replace it with 1. That's very useful. For example, let's suppose that you are some null values in a matrix, in a data set, and you want to replace these values, this missing answer, with the average of the column. So you can access everything that is like, for example, 0 or like none, and then just replace it with the average of the column. So as we saw in the penguins example, you can use the logical operators and or to combine like multiple comparisons. For example, here we have this vector, and we want to access the value where the vector is like bigger than 3 and smaller or equal 7. And then in the second example, bigger than 3 or smaller or equal 7. So in the second case, which values should we expect in the y variable?
All of them?
Yes, exactly all of them. Perfect. Okay, now I'll stop the recording and we can do some, how do I stop it? So now we're really starting the main part. I really think that once you master the if-else statement and the loop, for loop and while loop, then you can code virtually everything, at least in our field. And yeah, so we are really getting there. The if-else statements are pretty easy to understand once you get the logic. A quick example is if you have a driving license, you can drive a car, else take the bus. And that's basically how all these statements are structured.
Can you imagine a world in which there was a single rate for each parking garage? Neither can the garage owners. Whoa, those are some complicated rates. Fortunately, we can create code that behaves differently based on certain conditions, like the number of hours we parked in the garage. One way to do this is with an if-else statement. Let's use one to determine the parking fee for this garage. The variable h stores the number of hours parked. If h is less than or equal to 1, then the parking fee is 0. But if h is greater than 1, the fee is $5 for each hour after the first. Let's map this behavior to our if-else statement. We start with the keyword if, followed by an expression that must evaluate to either true or false. Next is the block of code that executes if the expression evaluates to true. Code after the else keyword executes if the expression is false. The end keyword marks the end of the if-else statement. So, for example, if we parked for half an hour, the expression in the if statement is true, so fee is set to 0. But if we parked for 3 hours, the code following else is executed, and fee is 10. Of course, it's common to have more than just 2 possibilities. What do we do if there are 3 or more? In this case, we used the keyword else if to add as many conditions as we need. Just like the if keyword, else if is followed by an expression that must evaluate to true or false. So now, if h is 3, the if condition is false, so execution moves on to the else if expression. This condition is true, so the code in the else if block is executed and fee is 10. However, if we parked for 9 hours, we'd probably be a little sunburnt. But also, both the if and else if conditions are false, and so fee is 35. And there you go. You can use if, else, and else if to write code that behaves differently based on a set of conditions.
Alessia, I think you're muted.
Oh, thank you. I would have just kept going. So yeah, no, I was saying that basically this logic flow is based on binary output. So if the statement, so the condition is true, then do command 1 that is expressed in the body of the state, in the body, and then end. If the statement is false, then you do the second command and then you end. And then, as we said, if we have more options, you can just use the else if statement. Okay, I think we can resume the exercise from the if, else if, and else part. So there is one at the beginning, and I think it might be a little bit tricky. So in case, do it in group. And I'll be around like every 3-4 minutes to ask how things are going. And so just let me know if you get stuck. So it seems it was pretty easy because you finished everything very quickly. So finally, we start to play with some real data and not just like exercises. And so we'll start this project that is based on some emotion evaluation, normally like specifically fear and anger, but if you want, you can also have more emotions to play with. And then politic ideology and punitive attitudes during the COVID-19. It's a data set that was that we got in April 2020. So I think it was right after, or actually during, the lockdown. So I would like to give you 3 options to choose from. So we'll have basically 3 different projects with the same data sets though. So the first choice is to try a project with minimal guidance. So I'll give you the whole data set, which is pretty big. There are a lot of variables. And then you can really try to play with it. So try to ask your own questions, do your own analysis. Of course, it's like I will give you some guidance on like what good, like which question you could ask and stuff like that, or if you get stalked. But basically you have complete freedom, and it's pretty challenging because the data set, it's a pretty big data set. Then the second choice is to have a project with moderate guidance. So I will just give you a section of the data set, and I will provide support for like basically I will tell you which analysis to do, and I will provide some structure in the code, and tell you how to set up, for example, a for loop, but I will not do it. And then the third option is the high guidance. So it's still a section of the data set, but it will be like step-by-step instructions, and it's just gonna be basically code completion. So yeah, so for today, we just familiarize with like a little bit like of the variables. So it's gonna be a section of the data set, and then you can think about it, and I will provide you the 3 options like later on. So you should have the My Emotion project file. It's pretty guided, this file, and there is a part that says like, okay, do it up to part 1, but if you finish, just you can keep going. And yeah, so today we finished the relational logical operators, and the Ifelse statements, and we started with an introduction of the projects. And next week is going to be a big day because it's all about loops, which is, I think, the most challenging part. And then, yeah, then we'll learn on the, so today was the 3rd class. So 4th is the for loop. On the 5th class, we're just gonna do some practice and so work on the projects. And then, yeah, then debugging, more projects, all the visualization. Matlab is great for visualization. And at the very end, how to write a function. Questions?